In this short video clip, we are going to discuss a useful property of expectation that is called the linearity of expectation. What is the linearity of expectation? Let's see. Let x be a random variable with support x1, x2 to xk. Support is the set of all the possible values that the random variable x can take. Also let a and b be two constants. These constants are not random. They are non-random numbers. I claim that expected value of a times x plus b equals a times expected value of x plus b. So it looks like you can treat the expectation sign as a linear function. Why is this true? Let's prove it starting with the definition of expectation. By definition, expectation equals summation over the support of over all the possible values that x can take, summation of this function of x times the PMF of the random variable x. We can first expand this multiplication and write that as a little x PMF plus b times PMF. If you're not familiar with the summation sign, just remember that the summation just equals a of little x1, the PMF at little x1, plus b of little PMF at little x1, plus a of little x2, PMF at little x2, plus b, PMF at little x2, plus to a little xk, PMF little xk, plus b, PMF little xk. So it's a summation of all the k terms over here. Realizing that this is a summation of these terms, we can group the terms. We can group the terms that contain little x times fx together, all of this together, and factor out the constant a, which is the same across all of this. So that gives us a times sum over little x, PMF little x. And then we also group together the terms with the PMF only, b times the PMF at these kx values. And that gives us b times summation little x, PMF little x. Now recall, this is the definition of expectation of x. So that gives us a times expectation of the variable, the random variable x. And this equals b, because the sum of the PMF equals 1. Because the summation is over all the possible values, the probability of each of the value summed up will be 1. So this proves the linearity of expectation. We use this linearity a lot, and now let's use the linearity of expectation to derive two useful properties for variance. One fact about variance is that when you apply variance on the linear transformation ax plus b, that equals a squared times variance of x. So what that means is adding a constant to a random variable does not change the variance, but multiplying the random variable by a constant changes the variance by that constant squared. We can prove this starting with the definition of variance. Remember, the definition of variance is that the expectation of the random variable here, ax plus b, minus expectation of that random variable. This difference squared and expectation outside. Next step, we keep the first ax plus b the way it was. Apply the linearity on this expectation, linearity of expectation on this expectation. We get a times e of x plus b. Now, inside this bracket, we have ax plus b minus a times ex plus b. The b cancels out, and the a factors out. So therefore, that equals a times x minus e of x squared. So that equals expectation of a squared times x minus e of x squared. Using the linearity of expectation again, this a squared comes out. So that gives us a squared times expectation of this square of difference between x and ex. And this, remember, this is exactly the formula for the variance of x. So this is by the definition of the variance of x. This is the first fact about variance that we often use. There is another fact about variance that can be useful sometimes as well. This fact says that variance of x equals expectation of x squared minus the square of expectation of x. How do we prove this one? Again, we start with the definition of the variance. And now we expand this square term inside the square bracket. Noting that this is expectation of three terms, the sum of three terms. By the linearity of expectation, this equals the sum of the expectation of each of the three terms. So that equals expectation of x squared minus expectation of 2ex times x plus expectation of e of x squared. So e of x squared is just itself, but noting that 2 times ex, this is a constant, it's non-random because we have already taken the expectation taking the average over all the possible values of x. So expectation is non-random, is a constant. Therefore, this 2 times expectation is a constant. By the linearity of expectation, it can come out. And we are left with e of x here. And the third term is expectation of a constant, because e of x is a constant. Expectation of a constant is the constant itself. It can only take one value. So that's e of x squared. Now notice that this second term is twice the third term, right? So one of them will cancel out, and we are left with e of x squared minus e of x squared.